The sun is just a tiny spotlight. A massive wall of ice surrounds all the continents. Gravity isn't real. These are just some of the core beliefs of the flat Earth model, a theory that has seen a massive resurgence online since 2015. Now, most people just argue about it in comment sections. We wanted to do something different. We decided to put the theory to the ultimate physical test. We built a complete working model of the flat Earth to see what it actually reveals, and the results were interesting. So, what is the flat Earth theory, really? Well, it's surprisingly detailed. The idea is that the Earth is a giant disk, with the North Pole smack in the center. Antarctica isn't a continent at all. It's a colossal 150-foot-high wall of ice that circles the entire perimeter, holding in our oceans. They say the sun and moon aren't millions of miles away. Instead, they're tiny spheres, maybe just 32 miles wide, circling a few thousand miles above our heads, kind of like a giant mobile over a crib. And gravity, as we know it, it's gone. In its place, the entire Earth disk is constantly accelerating upwards at 9.8 meters per second. That's what creates the feeling of gravity. These are some wild claims. And they lead to a huge question. If any of this were true, what would our world actually look like? So, we cleared out the workshop, grabbed our tools, and got to work building the very model they say represents reality. Our goal was simple: build their world by their rules. We started with a big, perfectly flat wooden disc. We put the North Pole at the center and sketched out the continents as they'd appear on this kind of map. For that infamous ice wall, we built up a high ridge around the entire edge, but the most critical piece was the sun. We mounted a small, powerful lamp on a rotating arm and hung it over the disk. This was our key to simulating the sun's proposed circular path above the Earth. According to the theory, this tiny local sun is what should create day, night, and even the seasons. The stage was set. Our miniature world was complete. It was time to see if this thing could actually explain the sky we see every single day. We decided to test two of the most basic things we all experience: the 24-hour day-night cycle and the sunset. First up, day and night. The theory says the sun acts like a spotlight, lighting up only one part of the disk at a time. As it moves in a circle, that spot of daylight moves across the world. Makes sense, right? We flipped on our lamp and started rotating the arm, and right away we hit a massive problem. Sure, the spot directly under the lamp was bright, but the rest of the board wasn't in darkness, it was just dimmer. There was no night anywhere on our model because the light source, no matter where it was always visible from every single point on the flat surface. Someone in our Australia could look up and see the sun, even when it was supposed to be high noon in America. This just completely fails to explain why half the planet is in bright daylight, while the other is in total darkness. Next up, we tried to create a sunset. According to many flat earthers, the sun doesn't actually sink. It just flies away from you until it gets so small it vanishes at a perspective point. Kind of like watching taillights disappear down a long, straight road. So we tried it. We put our camera down on one side of the disc and slowly moved our lamp away toward the other side. And you know what? The lamp got smaller, it got dimmer, it receded into the distance pretty much just like the theory describes. But here's the kicker. That is not what a real sunset looks like. When you watch a real sunset, the sun does not get smaller in the sky. Its apparent size stays almost exactly the same. What it does do is sink below the horizon line. We see the bottom of the sun touch the horizon first, then the middle, and then the top edge disappears. That effect is only possible if the surface of the Earth is curving away from you. A ship sailing away from shore vanishes hull first for the exact same reason. Our perfectly flat model could never, ever make the sun sink below a horizon. It could only make it shrink. Our model couldn't create a true night, and it couldn't create anything that looked like a real sunset. And these aren't small details. They're two of the most fundamental things we all see every day. The model also has no good explanation for why people in the southern hemisphere see entirely different constellations than people in the north, or why a lunar eclipse always casts a perfectly circular shadow on the moon. The truth is, this model falls apart because it doesn't start with evidence. It often comes from a deep-seated distrust of official sources and institutions, something that has flourished in the internet age. But science, at its best, isn't about trusting blindly. It's about being curious, testing ideas, and being willing to be wrong. It's about building the model, running the experiment, and seeing for yourself if it works. And when you actually build the flat Earth model, you see with your own eyes that the world it describes is simply not the world we live in. If you enjoy seeing wild theories put to a real physical test, do us a favor and hit that subscribe button because we have a lot more to get to.